I'm going to start the lecture on nanotechnology in chemical engineering. So, today we will discuss basically the chemical methods that are used for the synthesis of the nanomaterials. So, already there are various physical methods so that we have discussed. So, today basically we will discuss the chemical methods. The chemical methods, so many methods are available: colloids and colloid solution methods, and Langmuir blood-gate methods, microemulsion methods, sol-gel methods, hydrothermal methods, sonochemical methods, microwave methods. So many methods are available. So out of that, today basically we will discuss the colloids and colloids in solutions. So that is one of the chemical methods by which we can prepare different type of nanomaterials. So I said that there are so many methods of physical, chemical, biological or hybrid techniques that is are available to synthesize a particular nanomaterials. Here, since already we have discussed physical method of synthesis, so in chemical methods some advantages are there, so as compared to the physical methods. So in these chemical methods, that method is very simple, so simple technique, so we can use these methods to prepare a particular nanomaterials, and the methods is also inexpensive and less instruments that we have to use to synthesize a particular nanomaterials. That will be a nanoparticles, nanofilms, nanotubes, nanorods. So if you want to prepare, so simple means and instrumentation we don't need. So and also in this particular process the temperature is very also important, so we can use very low temperatures once we synthesize a particular nanomaterial. So very low temperature, so less than 350 300 degrees centigrade means usually 100 200 or 50 degrees centigrade low temperatures we can usually follow once we prepare a particular nanomaterials. Also doping of foreign atoms or ions, that is possible during the synthesis. So in chemical synthesis, so with a particular nanomaterials, if 1%, 2% or 5% any other dopants or other metals, metal oxides, if you need to add with the films to change its properties, so that possibility is there. Also through this chemical synthesis we can synthesize large quantity of the materials, the target materials we can prepare large quantity. So since the method is very simple, inexpensive, therefore large quantity materials also we can obtain through this process. Also variety of size, shapes of these nanomaterials is possible through this process. And materials, since we can develop or prepare the materials in the forms of liquids, means the nanomaterials that in a liquids we can forms, and after that when it would be recuts easily we can remove the solvent, and by drying powders or thin films we can produce easily by using that particular solute solvents by evaporations. That nanomaterials we can, depending upon our applications, there we can develop. Also self assembly or patterning is also possible. Therefore these methods we can use by using patterning or self assembly methods, so by using chemical synthesis. So here today we will discuss interactions, colloids and medium, colloids in vacuums, colloids in mediums, effect of charges on colloids, and steric repulsion, synthetic synthesis of colloids. So these are the things would be discussed at the beginning. So we will say what is the colloids, and colloids basically two different phases. So gas, solids and liquids, these are the three different phases. So when two or different phases of some different materials coexist with the dimensions that is in nanomaterials, or at least one of them, means there may be one or two phases or multiple phases. So one phases might be in nanometer range, so less than micrometer range or nanometer range. So then we can say that species or particles formations, that is colloids. Okay. So here's nanomaterials, that is the subclass of, it is a subclass of colloids. So here's you can see here's one material that is suspended in a particular solvent, so its size is bigger, so it is more than 100 nanometers, so that is suspended over that solution, so that is not, means its size is higher. And when the colloid solutions having particle different size, means 101 to 100 nanometers within that, so then it is like this. And when against that particle dimensions converted or into smaller range, so then actually that colloid formations or true sense it would be colloids. Okay. So this different way we can prepare the solutions, and depending upon the material size we can say whether it is colloids or not. So different type of shapes I said, so we can prepare that materials, plate types, fiber types. Okay, so here few examples we want to show what is colloids I said, and then so now if we give some examples then it would be very clear. So in gas, liquids in gas, that is one kind of say we can talk. So one example, so here tiny droplets of water that is present in air. So here is the solvents you can see, and water droplets that is in air. So this is water droplets and this is air you can say. So by that way they form say one kind of colloids, that is the fog is the colloids. Another one is the liquid in liquids. So here you can see fat droplets in milk, solids in liquids, toothpaste one example, and solids in solids that is tinted glass, and gas in liquids that is the foam. So one another example, so that is gas presents in liquids that form foams, that is colloid mixtures. So here in nature also there are many colloids is also present. So for examples waters and water bubbles that can also form colloidal structures in porous minerals rocks. So in mineral rocks if we notice, so there's we can get waters and water bubbles mixtures present in the form of colloidal structures. Also in there are some biological colloid also possible or exist, so that is in blood. So their corpuscles disperse in serum, so that is another colloidal mixtures or colloidal colloids, or in bones calcium phosphate that colloids embedded in collagen. So that is also another examples. So there are many organic inorganic materials that can be dispersed into each others, and we can develop or we can synthesize different type of colloids. So depending upon their synthesis and natural applications we can use that. So now we'll discuss about the interactions of the colloids with the medium. Colloids are the particles with large surface to volume ratio. So whence we prepare say colloids, their particles will be dispersed in particular solvents or a medium. So there's as a result surface area with respect to the volumes that would be increase. Okay, so at this stage whence that atoms on the surface that are highly reactive also, and that will interact to forms bigger particles or then maybe coagulate. So here you can see suppose we have a solvent, so there's colloid particles are present, or atoms or ions are present. They are moving with the help of Brownian motions, and they also interact with each other when there is a attractive force in between them with the particles. So they may grow and form say larger particles, that possibility is also there. So depending upon the solvents or a solvent when they are moving that particles, so they may grow and form a bigger or larger particles. So this is the Brownian motions of that particle present in colloid solutions, they are moving. Okay, so in that particular medium, so they make coagulates or may forms larger particles. Okay, so when they are present in the medium, so depending upon mediums also we can, if it is very dilute then agglomerations or coagulations possibility is less, or maybe some using some other externals reagents or chemicals we can easily grow that, so that may be grow or we can stop that grow or coagulations also. Colloids in vacuums in particles consisting of large number of atoms that I said. So when they come and interact between two spherical particles of the same materials and same size, that is very complex. The interactions in between two particles means I said so many particles are present, their interactions when they are moving with the help of Brownian motion, so they may interact with each other, and their interactions between these two spherical particles would be is very complex. So we have to, here you can see a colloid particles, this is a stable solutions means here, and this is not stable solutions. So here to make a stable solutions in the form of colloids, that is very challenging. So means when these particles moving, so they may aggregates and then forms larger particles, and then after that certain period of times they may sedimentation possible is there. So therefore the stability of the colloid. So, that is very important. So, when we are going to prepare a stable means colloid solution, the stability of that particles, these are the our study of interest of the materials. So, that is nanomaterials that we can prepare by using these chemical methods, but if the materials we have prepared that is not stable, so then means after certain times if it is sediments or forms larger particles, so then that is not good, or that we cannot stable colloids we cannot get. So, here's effect of charges and colloids. So, whatever the colloids that we forms that is in the liquids, that may be positively charged or maybe negatively charged or even maybe neutral charged. Okay. So, as soon as some charges on the particles or ions of the opposite charge, that would be accumulated or surrounded them. So, when a particles whatever the, if it is positive, then negative sides would be surrounded with that. Okay. So, that is called counter ions. So, what are the opposite ions that would be surrounded with that particles, that is called counter ions. Okay. These accumulations of the counter ions leads to the formation of electric double layers. So, when another layers is formations is there, so electric double layer formations would be there. So, due to the Brownian motions, these counter ions are not fixed, and all colloid events whatever the colloids present. So, there I said the particles are moving, and then some charges formations is there outside, and counter ions also formations would be there outer layers. So, by that way, so they may get some means here's one type of means layer formations is there, here another layer formations is there, and if it is let us say negatively charged colloid particles, so then positive charge will be counted here, layer formations would be there, another layer formation is there from this surface to this surface. If the distance if we consider, so within this particular layers, so the electrical potentials would be strong enough or this surface or this location, and from here to there, so that would be gradually diluted. So, okay. Since concentration of the electrolytes would be strongly affect the electric potentials. Okay. So, here since you can see, so let us say negatively charged plate is here. So, over there positively counter layer formations would be there. So, as a result the electric potentials will be developed here, and these electrical potentials you can see if you go from this particular point to this. So, then that electrical potentials will be gradually decrease. Okay. So, charge accumulations is very important. Okay. So, here concentrations effect of charges on colloids, when the concentration of the charges on the colloids and the local ionic charges in the solutions, that also contribute to the double layers. Okay. So, here's the solutions we are means use to form the colloids. So, there are some positive charges particles or ionic layer formations is there I said here. So, positive charge or negatively charged or even neutrals. So, that would be means concentrations of that electrolytes. So, if we use dilute or concentrated electrolytes, that also would affect the charges of that colloid particles. So, if we move from concentrated to the gradually dilute, so then electrical potentials, that electric potential that also will be decreased that way. Okay. Then effect of charges on colloid, two colloids charged colloid particles come closer and they approach to each others and then form a repulsive force. So, if highly means when a particles is their colloid in colloids and they are charged and electric double layer formations is there. So, when they come or approach to each other, so then there would be a repulsive force in between them would be there. So, then as a result both the particles will be stay away from each other. So, then since there is a repulsive forces, if the same charges are developed outside of that colloid particles. Okay. Repulsive force, therefore, when the repulsive force is there, that depends also low concentrations and high concentrations. So, if repulsive interactions for low concentrations, then that would set a longer distance, and if repulsive interactions for the high concentrations, so then at a smaller distance. Okay. So with the absorbing of some, means when that colloid particles develop some charges, so then they will either interact to each others and then they may be coagulates, or therefore to get a stable solution sometimes what we have to do means some adsorbing layers we can develop over the surface of the colloid particles, so that layers may be polymerics or organic molecules or inorganic on that inorganic colloidal particles. By that way we can, so two way we can develop that adsorbs layers over the surface of the particles. Suppose we have nanoparticles, over there some layers formations is there, that would be stay longer distance from each other, that particles, and therefore reducing the attractive interactions. Also by anchoring some long chain molecules or polymeric molecules on the surface of the particles, keep them apart with negligible interactions. Means these colloid particle interactions by using some polymeric molecules adsorbing layer formations over the surface, we can means get a stable solutions, or that particles can be stay away from each others. Okay, so by that way means I said that the develop of a colloid solution, stable solutions is very challenging. So many ways we can develop that. So synthesis, now we will discuss about the synthesis. Okay, so how we can synthesis a particular colloid or colloid particles or nanoparticles. So by colloid method. So here we can take some glass reactors. This is, we can say, is a glass reactors. Here we can use some inert gas. So the inert gas may be argon or nitrogen gas, and then one some stirrer would be there. So this is magnetic stirrer to get a homogeneous mixture of solutions, and then we can introduce some precursors. So with the help of syringe or somehow we can put the precursors, some temperatures control should be there, pH control should be there, and some surface precipitating molecules. So we can use that would provide sufficient steric hindrance that would inhibit aggregations. Means I said when that colloid particles will forms inside of that solutions, so they may coagulate or may formation larger or bigger particles. So that we can stop or we can reduce by using some surface precipitating molecules. Okay, so that also we can use. So now there are in synthesis when colloid particles formations is there, or synthesis of the nanoparticles in colloid method. So then there is a two steps, one is the nucleations and growth. This is particular bottom up approach. So in this we can categorize to homogeneous nucleations and heterogeneous nucleations. So in homogeneous nucleations we do not have to use no surface particles or surfaces that would promote to nucleations, means we will not use any externals or foreign particles. And in case of heterogeneous nucleations, so there we have to use some foreign particles that would provide a surface for nucleations to formations of that particles. Another one is the cavitations induced nucleations. In this case bubbles may form and that would be collapse due to the local changes in pressures and temperatures or formations of cavitations. Okay, so means high temperature or pressure that would be created during the collapse of the bubbles. Okay, so here graphically has been shown. So different methods, means how, means here's the nucleations growth and nucleations and fast nucleations growth and nucleations and growth of that nanoparticles. So here you can see the concentrations of that solutions. As solutions become super saturated and fast nucleations would be theirs, and some solid concentration approach point saturations. Okay, so here's depending upon that concentration, so up to a certain, here small particle formation is theirs, and then after that some agglomerations and growth would be theirs, larger particles formations is theirs. Okay, so nanoparticles would forms. So in another type, that is the aggregations, that is curve B you can see. So here nucleations growth would be slowly. So in this case nucleations growth would be slowly, and then particles formations would be there, but in this case particles may not be uniform size, and this way particles forms what is, that is less stables. Okay, so in fast nucleations and growth, here the nucleations process is fast, and that way we can forms that nanoparticles. Okay, And another one is that is very slow process, means it is extremely slow process when the nucleations and growth process, that is very extensive, means long period of times it would takes and for the growth of the nanoparticles. And in this case actually larger particles formations is there or possibility is there. Okay. So now few examples will show how different type of nanomaterials we can synthesis by colloidal rules, gold, silver, palladium and copper nanoparticles. So that will discuss here for synthesis of the gold nanoparticles. So here we have to consider some reagent or reactants we have to use, chloroauric acid that we have to use as a reactants, and with that trisodium citrates that would be used in waters. Okay. And here is the reactions, you can see the reactions will take place and gold nanoparticles will forms, and by reductions of these gold precursors by using trisodium citrates, so nanoparticles will forms, and when nanoparticles formations is there or their color change is there, so means initially gold nanoparticles that colors may be red colors and then it would be changes into magenta depending upon that particle size. And when this gold nanoparticles is formation is there, so means it was started from these iron 2 metals 0 states, it would be agglomerates or condensation. So smaller to larger particles formations is there, and then electrostatic stabilization. So here each nanoparticles is stabilized some capping agents. Here we have used trisodium citrates, that is the capping reagents. So that stabilized the electrochemicals double layer formations, and that stabilized the nanoparticles that would form during the reactions. So here some others nanomaterials, that is cadmium sulfide or zinc sulfides, that also can be prepared by these colloidal routes. So here you can see different type of precursors for the zinc sulfide preparations, zinc sulfate, chlorides, nitrates or acetate type of the materials as a precursors we can use. And see here we can use sodium sulfide, that is Na2S, that is H2S gas as a source of sulfur. So this is the reactions, basic reactions. So basically that precursors will be taken and then H2S or sodium sulfide that would be passed through these solutions. These zinc chlorides will be taken and H2S or sodium sulfides Na2S that would be passed through this H2S or sodium sulfide reagent will be given, and then these reactions will take place and the zinc sulfide nanoparticles will forms in that solutions. As another example is zinc oxide nanoparticles. So zinc oxide nanoparticles also we can prepare. Here we have to use zinc chlorides, that is as a precursors in waters, and we have to add sodium hydroxide, so that is base. Basically this is the reactions. Here these two will react and will get hydroxides, basically zinc hydroxide that would forms in solutions and as a in the form of precipitate, and then we can dehydrates, means if we remove waters molecules from this hydroxide, so then zinc oxide nanoparticles will forms after drying, so we can get that. Okay. Then another example is selenide nanoparticles, that also we can prepare by chemicals route or solvent solutions route. So by preparations of these methods also similarly precursors we can take and we can prepared by precipitations that particular nanomaterials. Surface passivations and chemicals capping. So capping materials I said when colloidal nanoparticles when we forms in a particular reactions in a solutions, so there is a possibility of coagulations or ripens due to the attractive force between these particles. So therefore to get a smaller and stable nanoparticles or to get a solutions colloidal solutions containing nanoparticles, so sometimes we have to use some capping molecules. Okay. So stabilize the nanoparticles in that particular solution. So instead of, since this is our stable solutions, when some means after a period of times we can see that, so due to the attractive force between these particles they may coagulate and may forms larger particles, so that is not desirable. So therefore to make that solutions or nanoparticles in that solutions in very small nano range, so So then we have to use sometimes capping reagents, I said capping materials or molecules, or sometimes polymeric materials also make coats over the surface of the nanoparticles, so that can prevent them to interact with each others and coagulations. So there are many chemicals means capping methods are available. So usually at high or low temperatures we can use these capping materials for these particular reactions. That depends on that particular reactions. Usually 300 to 400 degree reactions we use for the preparations of the colloid synthesis or these chemicals routes. So here's organometallic compounds like dimethyl cadmium for selenium powders that are injected into the solvents, trioctyl phosphines, topo. So at 300 400 degrees centigrade, this is the topo. So these reagents, trioctyl phosphine oxides, so we can use when we are going to prepare some cadmiums related or selenium related compounds or nanomaterials. So this acts as a stabilizing reagents. These materials, this we can use organometallic compounds as a stabilizing agents or this. Then size distributions of the nanoparticle size sets, many way you can control by number ones withdrawing the aliquots. So in any solvents, so there we are preparing the nanoparticles. So once it is forms, we can take out that solutions or aliquots. Okay, so at different stage of the reactions we can take out that solutions. By that way we control the size of the nanoparticles. Okay, or by adjusting concentrations of the capping molecules. So I said that some capping molecules also we can use means to stop the agglomerations or coagulations of that nanoparticles when they are present in the solutions. So therefore by adjusting the concentrations of the capping molecules we can control the size of the nanoparticles, or by withdrawing aliquots where that nanomaterials will be formed. At different stage we can take out that aliquots, and by that we can control the nanoparticles. Okay. So next is the stability of the nanoparticles. Chemically stable over a long period of time. Since nanoparticles are chemically stable over a long times, therefore thermal stability of these particles depend on the capping molecules that we are using. So depending upon that capping molecules also, the stability also either increase or decrease. So which particulars, there are various capping agent or capping molecules are used, so that can stable or stabilize the nanoparticles when they are in solutions. Here a few are showing here: thiophenols, so or ethanols, or sodium metaphosphate. So this is another. So these are the difference means inorganic molecules, so that can be used as a capping for metal sulfide nanoparticles production. So that can stabilized when that metal sulfide is forms in a particular solutions. So they can stop that coagulations and for the formation of larger materials or larger type of particles, nanoparticles. So there are some advantage of using capping agents when we are getting a stable nanoparticle solutions. So I said that when we are using some capping materials, when nanoparticle formations is there in a solution, so that nanoparticles are chemically stable over a long period of times. Okay. Also thermal stability also, that depends upon the capping molecules which are using. So usually these organic molecules, what are the capping agents we are using, that nanoparticle stables up to 200 250 degrees centigrade within that range. Okay. So now different solvents also we can use, different solvent pairs also we can use for the stabilizations or the formations of the nanoparticles in a particular solvents. Okay. So there are different solvent pairs also: pyridine, hexanes, chlorphormethanols, dimethyl sulfoxides and diethyl ethers. Different solvent pairs also we can use to stabilize that solvents, insert stabilize the nanoparticles in that particular solvents. Okay. So the particular solvent is very important for a selective in nanoparticles, so where the nanoparticles will be in stores or would be for a longer period of times. Okay. So okay, so today is up to this. So different type of solvents we can, or solvent pairs we can use for the stabilizations of that nanoparticles that would be dispersed in that particular solvents. Okay, so today is up to this. Okay.